Hi there, this is Andrew Brody with Yokogawa's Control Instruments Business Unit, and today I'd like to talk to you about Stardom, our process automation controller and remote telemetry. Stardom consists of three different models. The first is for high reliability situations. We can support redundant power supplies, redundant CPUs, redundant field bus communications, redundant serial communications. The only thing we can't do redundantly on this is straight redundant I/O. We include communications to various smart protocols for I/O, such as HART and Foundation Field Bus on this unit. We also have a lower power consumption model. This is the FCN RTU. The FCN RTU is designed for places like well pads or places that might have thermoelectric generators or other types of local generation where power is at a premium. Has very low power consumption. In fact, the model shown on the screen here in the middle is essentially a power supply, CPU plus built-in I/O, and then 3 expansion slots. We can actually take this same guy here and put it on the bigger frame up here to give you a total of 8 expansion slots after the CPU. Even fully loaded with lots of I/O, we're at about 25 watts. That's with 8 expansion cards at a maximum drainage situation. So you can actually put in very large I/O count installations at a very reasonable power consumption. Since this one is designed to operate in outdoor situations, it's got a wide operating temperature range of minus 40 degrees to 70 degrees Celsius at up to 3,000 meters. It once again has the built-in I/O in the CPU module. It's actually got a pretty good I/O count, and we'll cover that a little later. It too supports the HART and Foundation Field Bus protocols off the I/O. And the last model we have is kind of a node expander, and we typically pair this one up with the FCN. The FCJ has a good variety of built-in I/O. It also has an option for Foundation Field Bus. And one of the reasons we pair this up with the FCN is it also has the built-in redundant Ethernet. So as we can see with the FCN up here, it has 2 Ethernet slots built right into the first CPU. And if you have a redundant CPU, it's the same deal there. For this guy here, you can't really see it, but on the side of it, it does actually have the 2 Ethernet ports built into it. So once again, you can have redundant communications for high reliability situations. Moving on, this is kind of how we've positioned them. So for compressor stations, pipeline utilities, high reliability, high speed type situations, we've got the FCN up here. We've got the FCJ as a node expander, and we see that just kind of where you need all-in-one, slightly lower I/O counts, but maybe you want to take advantage of the redundant communications. And then the FCN RTU over here is your more extreme power conservative type situations, lower I/O counts. So let's take a look at the main FCN unit here and see some of the capabilities of it. We can see it has a Pentium CPU, so this is a fairly powerful CPU for this class of device. It has a 128 megabyte memory ECC, so this is the same type of memory that you'd find on high-end servers to make sure that a memory error isn't going to result in a control error. So it's a very robust type of memory. It comes with the redundant Ethernet ports that can be set up in a redundant manner or just completely 2 separate networks. It also has an RS-232 port, maybe for like attaching an HMI panel or talking off to some type of serial device. It has a couple different power options. It can be the AC power, both national and international, and 24 volts DC as well. I/O modules, wide variety of I/O modules, all the typical that you'd expect for analog, your 4 to 21 to 5s, plus or minus 10 DC volts. We support HART I/O as well, RTDs, thermocouples, millivolts. And typically these analog I/O modules, they're high density compared to what you might find on a RTU. And these are applicable to both these chassis and the FCN RTU chassis. So for the analog modules, you're typically going to see 16 for your currents and your voltages and thermocouples, and 12 for your RTDs per module. And we have a choice of isolated, non-isolated, channel isolated. So it just kind of depends on what you're looking for that I/O. And we can also do two-wire devices off these, and we can power them through those two wires. So kind of built-in power across the backplane to power up your I/O modules for true two-wire instruments. Digital modules, wide variety of digital modules, including DC, AC, pulses, relay outputs. We also have a high-speed turbo machinery module. So this is really good for your compressor control stations and anything with high-speed rotating machinery. Communication modules, we have a RS-232 and an RS-485. Those typically come with a couple ports on it. We also have a foundation field bus, and those can be deployed multiple, I believe up to 7 per system, and they can be installed in a redundant configuration as well. We also have, this is very nice for remote expansion I/O. We can take advantage of various slice I/O systems like the ones made by Phoenix Contact. We support OpenCAN and Profibus DP. So those are excellent ways of getting class 1 div 2 remote I/O, say at a well pad or some smaller installation where you don't want to install a full backplane, and you can put those in very cost effectively. In terms of expansion, this supports 3 backplanes, and we also support redundant backplane communications. And that's kind of what this little picture over here is showing. So we're showing the redundant power, the redundant CPUs, the redundant communications network capability, and then over here on the right-hand side is the redundant backplane communications. So these can be deployed in singles or in a redundant pair like we're showing here. And then we can kind of see if we do not do the redundant backplane communications, we can have up to 25 slots of expansion I/O. And then if we do go the fully redundant, we get 20 nodes of 20 slots of redundant backplane communications and I/O here. Moving on to the FCN RTU, we can see that it has a reasonably powerful CPU for this class of product. Once again, it comes with that error correcting checking memory. Has a built-in Ethernet port. Has 4 serial ports, so 3 RS-232, 1 RS-422, 485. Typically, I see these used with Modbus RTU protocol, but I've also seen them used with stuff like HMI panels, as well as thermal ticket printers. So you can kind of do your own custom protocol with the unit if you want, in order to talk to maybe something like a base station or something like that that might have its own ASCII type protocol. It has low power consumption. It's good in various different environments. Has a good chunk of embedded I/O as well. It's got 12 points of analog, 1 point for battery monitoring. Has a couple analog outputs. This is good for stuff like PID loop control. It's got 16 digital input points, 8 digital output points, and it's got a couple high-speed pulse points for doing stuff like PD meters and other types of flow meters that could generate pulses for you. It can run on a wide variety of voltages from 10 to 30 volts DC. It's a high-efficiency power supply module. It also has access to all the I/O modules that you've seen with the regular FCN. And for an RTU, these can be very high density. Like when we get into the digital modules, we can actually do 64 digital ins and 64 digital outs on one module. So once again, that's 64 digital ins on one module, 64 digital outs on the second module. So I'm not talking 128 points on one module, but still 64 points on a single module is pretty good for this class of product. It also supports your foundation field bus, it supports your heart, and this guy here shows it with a 3-slot expansion, but I can also put this guy in the bigger rack and give you 8 slots of expansion. So very nice setup Of course, it works with solar power and battery arrays. It also has a wide variety of communication options and protocols, works great with cellular modems and some of our other radios. We have a wide variety of radios available, including Radio I/O. We have, it's called www.dawn, DAWN, wireless.net. You can check out some of our radios there. And the final unit we have is the FCJ, once again, same Pentium CPUs, the FCN. It continues on with the ECC memory. It has a couple Ethernet ports and a couple serial ports. So once again, you can do your redundant serial and redundant Ethernet communications if desired. It's got a good chunk of built-in I/O, so 6 analog inputs, a couple analog outputs, 16 digital inputs, 16 digital outputs, and there's an option for putting on a couple of foundation field bus segments as well. And it's 24-volt power. In terms of functions at a glance, what do you get inside the Stardom unit? Well, you get a durable design. They all come with high-speed CPUs, the hot swappable I/O modules. There's tons of diagnostic variables available for your SCADA packages and HMIs. Networking, the FCN and FCJ can come with redundant Ethernet communications. They can also do redundant serial communications, which is nice. They're ideally suited for low bandwidth communication where you might have either a satellite radio. It's designed to work out in the field. And then, of course, we can do redundant control, foundation field bus, OPC. So we have support for definitely solid communications there. In terms of programming, we support IEC 61131-3, 5 languages. So this is stuff like ladder logic, function blocks, structured text, stuff like that. We also have a wide variety of libraries of function blocks and code pre-written to help speed up your development. We can do online downloads. We can do software wiring. So this allows you to essentially test without having your instruments installed, as well as a simulator, so you don't even need to actually have the hardware there. You can run the simulator right on your PC, so you can kind of test in your hotel room or back in the lab without actually having the hardware right there in front of you. We also have some other neat features that are somewhat unique to the Stardom series. We've got InfoWell, which is a combination of being able to do web pages, data logging, emailing, FTP. For those familiar with our data loggers and data acquisition systems, it really combines a lot of that. So we get to see the web pages, data logging, email, FTP, event notification. So quite full features. So not only can it do control, it can kind of do all those advanced web features that we've come to expect from Yokogawa products. So let's kind of take a look at this in a more pictorial format, what I was just talking about, the InfoWell. So we can see we can put custom web pages with trends together, reasonably easy. We can do process control. So we've got, of course, wide variety of outputs, including analog outputs. So that allows us to do full PID style control on the unit. It's got good built-in web functionality to do FTP, email, data logging. In terms of field networks, we have lots of communication capabilities. Some of these you might only find on DCS classes of products, but we can do full foundation field bus communications, off to devices, Modbus. We can also do HART communications off to devices, graphic panels through, say, the either Ethernet or serial communications. So let's take a look up here. So we've got the foundation field bus, HART, Modbus, DNP3. We also support OpenCAN and Profibus DP. These are excellent networks for remote I/O, kind of slice I/O. These are some of the typical deployment situations we've seen. So up here, we've got a FCN with all types of field instruments hanging off of it. And a couple of the neat things we have going on here is we have PRM. This is our asset management system. And if you have a HART system or a foundation field bus system, we can do full pass-through over Ethernet down to the instrument. So now you can kind of bring in all your diagnostics and other types of information, calibrations, stuff like that, that would be nice for an asset management system. We also have tight integration into our SCADA package, which is called Fast Tools. So once again, we can, if we have, say, PID loops deployed up here, we can very quickly automatically kind of build them in. So almost a little bit like a DCS, where we can take the hardware at the bottom level and automatically put our faceplate system. So for people familiar with Yokogawa's Centum system, or even other DCSs, it's very common to be able to take PIDs that are generated in your control package and pop them up right on your supervisor package. So we've got a nice combination there. And then over here, we're showing foundation field bus connectivity from an FCJ. We're showing cellular connectivity to an RTU, so we can do cellular communications quite well. If we go down here, we can kind of see how we integrate into a DCS. So we can either integrate in through Modbus, whether it be serial or Ethernet, into DCSs. If you happen to have a Centum system, we can come in through SIOS, or if you have a newer Centum system, we can come in through the Universal Gateway system, which makes it very easy to come straight into Centum. Also, if you have like an ALR card or an ALE card, you can actually deploy Modbus on your Centum system and come straight into Centum via the Modbus I/O system. Here's another one on the PRM system, so we can kind of see we're coming over through our I/O networks here. So we can come in through Foundation Field Bus, we can come in through HART, we can pass right through the Ethernet ports on the Stardom unit, straight into PRM. That can be used to synchronize with something like Maximo or other products of that class. You can bring in your diagnostic data, kind of like your total cycle counts, your travel distance, open close time for your valves, little things like that that are going to help you do a better job of diagnosing your process. I wanted to talk about one special thing that Stardom has that just about no other control system has on the market, and that is the ability to deploy applications on top of it. So you've seen that we had fairly beefy CPUs and a good chunk of memory on them. Well, Stardom's one of the first controllers out there that can actually have apps deployed to it. So taking advantage of its programmability, you can put Java programs on the unit. We've deployed something called Well Producer. So this is kind of the first app that we've deployed on top of Stardom. And in this case, Well Producer is a layer that turns it into a configurable well production system. So in this case, we can have a couple wells. We can have built-in control programming like plunger lift. We can have your full electronic gas measurement or electronic flow measurement. So we can do all your AGA calculations like detail, gross 1, gross 2. You can do all those types of methods for your gas calculations. We can also do your net oil computing functions, do emergency shutdown. We can do verification and calibration logs. So here's an app that's deployed on top of Well Producer, and we can talk how to either customize Well Producer to fit your needs for gas production, or we can potentially build a new app that's going to turn Stardom into the precise piece of equipment that you need to control your process. Here's a further dig into what we did with this app capability on top of Stardom. So you can kind of see here's using a bit of the InfoWell functionality where we can deploy custom graphics. We can overlay data on top of it, so it kind of gives you a light SCADA type feel. We can also put in kind of tabular data, some buttons, stuff like that, to allow you to do various configuration and selections. So, well overview, ESD maintenance and override, operational parameters. This is just an example of deploying apps on top of Stardom. In terms of Stardom support, it spirals outwards from you, the customer, and where that would show up first is we have local representative partners, Mexico, Canada, United States, all located reasonably close to you, the end user. We then have a set of Yokogawa regional sales engineers, regional sales managers, application engineers. We have operational engineers as well, designed to deploy and support larger projects. We have some international subject matter experts in various places, whether it be for oil and gas or hydro or wind. We have people that can cover just about every process that you're looking for help on. And we also have a great team of product management and development engineers standing behind the product to help you deploy customized solutions. So that's Stardom, and it's a very flexible process automation controller and remote telemetry unit. You can do everything from redundant I/O to custom deployed applications, and has a wide variety of communications available for you to handle just about any type of process engineering challenge that you may need. So take care and have a great day.